We already have our next speaker. We already have our next speaker with us. He'll be talking, we're going from under the sea to on the rail, so it's kind of a hard shift of looking at the different industries. We'll have Thomas Thiele from Deutsche Bahn with us. He'll be talking about extending mobility, how AI contributes towards the future of railway transportation. You're with Deutsche Bahn since 2018. You have a variety of expertise, mostly working on the development and implementation of AI-relevant topics within the company. And you are the coordinator of the House of AI. We already heard a lot about that today, so we're really interested to get your perspective on what you're doing and what's the AI transformation at your department. Thank you.
Hello, welcome everybody. So thank you for the kind introduction. So let me first start now. You just mentioned the House of AI. So it's part of the central of Deutsche Bahn AG and the central unit for the strategy, governance, and of course implementation of strategic use cases at Deutsche Bahn. So we are closely working together with people from our business units in order to solve our typical problems at Deutsche Bahn. And this is also the starting point of my talk, our current situation. So I think some of you guys took a train to this conference, took the commuting trains, or at least the long-distance trains, and that is the one situation most of you guys will face when you take a train at the moment. So in long-distance trains, we are roughly about 60 to 70% on time, which is quite an issue for a company that measures their impact based on their punctuality in this point. And the idea behind a lot of topics at the House of AI is how can we become better in our railway operations, in our core processes, which we call production at Deutsche Bahn. So all the processes we do daily that keeps trains running, from maintenance to capacity management. And especially with that, we have a vision that is, of course, here presented for capacity management, but might also be in use for a lot of other topics in the idea of AI at Deutsche Bahn. Our job is to support colleagues at our business units before, during, and after a train journey. So we cover all the steps from planning to train operations and all the things that are done afterwards, from getting data out of the trains to digital maintenance, to make best possible decisions and for improved rail operations. So we especially tackle all the problems from an overarching perspective. What can we do at Deutsche Bahn with methods of data and AI to do things better for you as customers? And this is a vision we can't achieve on our own at the central unit. So basically, we are the AI guys. We centralized expertise for that topic. We centralized expertise on data. You heard my colleagues Stefan and Carsten before for a lot of data and the overarching topic, data intelligence. But also the business units. So we are bringing together the experts from centralized units to the business units, which are the domain for our applications, which cover the needs, which bring in the requirements. And we are realizing the requirements in close collaboration with the business, and on the other hand, with internal and external service providers here to make those things happen. And I brought to you 3 examples for things we do before, during, and after the train journey. And I would like to start now with one very concrete project. So expect delays. I just mentioned the current situation, and one answer to this question, why so many delays happen, is the current situation of the tracks, meaning that we are doing a lot of construction works to improve the network, to keep the network running. And one core project in that area is presented here, where we brought together all the data from construction sites, from construction measures at DB Netz. So this project has been initiated by colleagues of DB Netz, which built the first prototype, is based on a platform provided by our colleagues at the DB Netz CIO area. I can refer to my colleague Nina Stumme later on for a talk on that. But here you see one result which helps people to get an overall perspective on the different the different construction situations at Deutsche Bahn, which means that we also lowered boundaries in the construction planning. So you can imagine that at DBNet we have 7 regions, and especially at the boundary of those regions, there's a lot of manual work for the planning of those construction sites, and the idea was putting on together the data of many thousands of construction sites into one centralized view to reduce manual planning effort on the one hand, and now getting onto the next step, using this as a basis for AI as a support in the planning. So bringing together, on the one hand, what capacity is planned on the track, and of course, in the next step, what could be recommendations to lower the capacity in order to make trains be more on time. This is a planning aspect, of course, because when you look at this depiction on the right side of the chart, we are 30 weeks before the schedule has been initialized, is running. So we finished the project right on April, which means that the travel on Xmas could also be improved with this tool. And I'm happy to hear your feedback in a year if that has happened. Let's move on now. When the train is already running, we started 3 years ago with the implementation of what we call KI Dispo, an AI using in dispatching of trains. So the train ride started and there is some error occurs. For example, trains have been delayed, coming together at a crossroad. Dispatching agents have to decide which train goes first, for example, with a very simple case. We built up a reinforcement learning approach, which is currently in use by commuter trains or by the commuting trains at DB Regio. That is based on a simulation based on real world data. We have around 13 seconds delay to the current operations, and there's an AI on top that with the multi-agent systems that covers certain areas of the map. And you see here a depiction of the first region where this tool has been deployed. It's the region of Stuttgart. And we have, for example, here a multi-agent network of 2 agents supervising 2 central areas at the so-called Stammstrecke. Stammstrecke is the central part here on the railway network, and all the trains have to go through this area. And if you're able to, on the one hand, use the simulation to coming from I only see what currently happens to see what happens next. So we have this YouTube style player here. You can do some forwarding in the traffic and see how the traffic is going to develop around the next 30 minutes. And then have the AI that is depicted here with the red square on the right side that gives you recommendations. So in the next 30 minutes, you will see here the train 7113 have to go before the train 28307. And you can do this in advance. You have much more resilience in the system. People can foresee what happens, and we come from reactive to proactive dispatching. And there's a pretty good benefit on that. So we already reduced around 30,000 minutes of delay for the commuting trains in 2022, which is quite large for the commuting trains. And we are going to develop this system also for further commuting trains and also large areas. And the last category, XPost Analysis. So if we come to some sort of feedback for our different drivers of the trains based on data, we come to this project here. We collect, since 2020, all data from so-called tachographs, black boxes in the train. So all the data from bus systems, from security systems come together in one black box. We use this data to give the train drivers a certain feedback if something happens that should have been happened. So, for example, if a brake is hit when a brake shouldn't be hit, that's one issue. So the direct feedback for the people. And the other one is depicted here, where we use trains as some sort of sensors for the infrastructure, which means we use the data from the black boxes, depicting where a certain event occurs, putting it on a map, and see now if we have any clusters on that. And if we have any clusters on that, it might not be a human failure only, but also the reason comes through, well, is there something in the infrastructure? Perhaps do we have to change the signals? Is there any vegetation on the track or something like that? So we using data here to improve our perspective on the network here and identify weak spots in order to reduce the number of events and come to a resilient train transportation. And in the vision, I presented 3 initiatives here that are they stand alone at the moment, but the idea is bringing them together. Bringing them together on a data level, so I think the idea is quite obvious. We have data in the planning, we have data on the train operations, and also we have data that is collected afterwards, after the train ride. And the idea is bringing those data together to some sort of a holistic view on the databases, and then connect also the analytics part. So what I just presented an idea where we use data already on a map depicting on, so there are certain occasions, certain events, why did these events happen, what can I do to neglect the events, and also come to some sort of improvement here. That's one aspect for the people to identify hotspots at the network. If we follow this idea further, we can also integrate this data into the planning process. Yeah? So, for example, if we come together, we use the data from construction sites depicted at the first case, bringing together data from the black boxes from train operations, a lot of different actions occur, a lot of different events occur, and bringing together the operation side, the planning side, and the maintenance side in one connected perspective, with the idea of getting a whole overview on the DB network system and, of course, the interaction of trains and the network. And the idea behind all this, becoming more adaptive. So coming from react on certain events to predict certain events. The idea is here a better optimization of the system, a better support of people in train dispatching, train steering, and become more resilient. I just mentioned that a few slides before. When it comes to minimize the effort of disruptions, we will always have disruptions in the train system in Germany. We have an open train system, so we want to come to a station 2 minutes before the train leaves. That's one very good thing, in my opinion. But the idea is if we stay with this open system, we always have disruptions, and the idea behind all the different connected data implementation of AI is to minimize the effects of disruptions in that system, which will always occur. So now I'm at the end of this presentation, and I think we have also some time left for questions. So thank you very much.
Thank you very much. Yes, we indeed have some minutes left for questions. So again, my question to you in the audience, do you have any questions? And I'll kindly ask my colleague to hand over the microphone. Please quickly say who you are and what company you're representing.
Yes, thank you very much. I'm Christina Hensch, and I'm coming from the Deloitte Consulting. And just literally a very simple question here. You talked about the predictability of how far can we see in future what happens. Could you describe what's the further outlook that you can get, like in time? And second question is connected to that, what does make sense? So are we talking at some point about Wahrscheinlichkeiten? Probabilities, yeah. Or like in percent, or how does that look?
Yeah, so we're still in the process of figuring out how this probability of predicting the right situation goes down. So at the current situation, we cover around 30 to 40 minutes. The feedback we get from the dispatching agent is, well, this is quite good. And I think I have to mention the data that is used to make this prediction, especially in the simulation of train dispatching I just mentioned. So if you're a user of DB Navigator, you see punctuality prediction. Yeah? My train is on time or not, at +6 or +5. Some people say +20, of course, also. And we also cover up this prediction. So within the simulation, we do not use the real-time data, but also including the prediction. And we therefore have also this prediction and covered with the same information the customers have. So basically, this is one perspective and the same perspective, which is, from my opinion, a very good idea.
Thank you very much. And we see. Thank you.
Hi, I'm Daniel from DataIQ, and I would love to learn more about what kind of key learnings you pulled out of these 3 use cases, as I understand your organization, you're basically like a center of excellence, but you work with the business domains on that. And maybe you can share a bit how that collaboration went and what best practices are there.
Yeah, sure. Very good question, to be honest. The main idea is that we present an offer to the company. So it's not about presenting a technology push from the central unit that says, well, everything is AI now and we solve all problems of DB with AI. That's not the issue. The idea is we have certain topics where we can help. It's an offer from our central unit, and we follow the idea of a technology pull. So basically the business units say, well, okay, we had the idea of doing something with the data, let's talk about it, and maybe we can figure out if there's a project that could be put together, and also put together with combined resources. That's a very strong point. We put together also people from different business units, from our service providers, and also the money for that together. And second, most striking point for me, it's not about the technology. We always figure it out to implement it, that it works. It's mostly about culture and processes. So we follow the idea of people, culture and organization, and technology, of course, to bring the use cases to an impact.
We have time for one more question. Yes?
My name is Ralf Kemperdick. I'm the Big Data Lead of the AI work group here, and I'm employed by Microsoft. I have a question with regards what you just mentioned. Would you phrase these processes as an MLOps process, where you bring together the technology, the people, and have you kind of a governance layer, or do you control in a way, and how do you control the outcome of the processes? Is there some quality gates built in this DevOps, MLOps?
Yeah, we have some sort of quality gate, quality assurance. We developed some sort of stage gate processes with four maturity grades. So we start with a very small feasibility study covering if this problem solvable using data and AI, roughly 3 to 6 weeks. Then doing some sort of prototype. If we decide it would be fruitful to continue, then afterwards, second stage gate from prototype to MVP, starting the production phase, which means we now decide whether we implement a full architecture, and of course an architecture that is ops ready, and that is where MLOps comes in. So at this phase, the MVP phase, we start to build up what we call an operations team for the different use cases. The idea is that the people that build the system run the system afterwards, so we cover up the one core rule of MLOps at this point, and also implementing the right tools for a no-ops vision. Of course, this can't be achieved, but it's the aim to do it to develop it like this. And this starts with the production phase latest with the fourth step, and then after operation is secure, the integration into the processes of the different business units is assured, we will be leaving this project to the business units and the operations team.
Thank you.
Thank you very much, Thomas. Our time is up now, but thanks to you in the audience for asking questions. Thanks for sticking around. I'm sure if there are any follow-up questions, you and your colleagues from Deutsche Bahn will be here today and potentially also tomorrow. So if you have any questions, feel free to always approach our speakers afterwards individually. Thank you very much.
Thank you too. Bye.